Infinitely many possibilities. So an exponential function will be of the form y equals a b to the x, to the power of x. Exponential functions have variables in their exponents. Exponential functions have variables in their exponents. There are infinitely many possibilities for b, and therefore infinitely many possible exponential graphs. We're going to look at y equals 2 to the x, where this is actually y equals 1, 2 to the x, technically. Because if there's number in front, your a is a 1. So, if we want to find y, we just have to go 2 to the x. So in this case, our y is going to be 2 to the negative 3. What's 2 to the positive 3? 8. What's 2 to the negative 3? 1/8. Because this is just 2 to the negative 3 is the same as 2 to the negative 3 over 1. Kurt's told us this. We can drop it to the bottom and put a 1 on top. So this becomes 1 over 2 to the 3. If you want to make it a positive exponent, you can drop it to the bottom. Put it under 1, which is 1/8. This one's going to be 2 to the negative 2. 2 to the 2 is 4, so 2 to the negative 2 is a quarter. 2 to the negative 1, 2 to the 1 is 2. 2 to the negative 1 is a half. What's 2 to the 0? 1. What's 2 to the 1? 2. 2 to the 2, 4, 2 to the 3, 9, 2 to the 4. That's not, it's an 8. 16. I did 3 squared instead of 2 cubed. My brain played them. Okay, let's plot it. So we have negative 3 and 1/8, really close. We have negative 2 1/4. We have negative 1 1/2. 0 and 1. 1 and 2. 2 and 4. 3 and 8. Then we ran out of room. Now what's happening if we do this more, we have 1/16 and 1/32. It would be really, really, really tiny, right? As we go this way, they just get super, super, duper, duper crazy close to the x-axis, but they just don't touch it. So that one runs that way. And then this one runs this way. And this is going to run closer and closer and closer to the x-axis, but never touch the x-axis, because there is actually a horizontal asymptote on the x-axis. So that's that electric fence that if it touches it would zap it. So it won't ever cross it or touch it. So this is a horizontal asymptote. The x-axis is what line? Y equals 0. Is this function growing or decaying? Getting larger or getting smaller? It's growing, right? Okay, type y equals 2 to the x in your calculator. I would go zoom 6. There, ooh. Clear that out. And we're going to go 2 to the power of x. I'm going to press graph. Do you see that? Okay, let's type in 3 to the power of x. And for y2.
If you put a stored as an x a while ago as something else, is it going to still be like that number?
Not for your graphs. It would be for your main screen.
Well, how do you get
The moment you find a new intersection, your x changes. So if you found an intersection today, your x has changed. It won't affect anything unless you type an x into your main screen. Yeah, it won't affect your graphs or anything. So red is going to be my new one, 3 to the x. What happened? It's growing faster because instead of doubling now, it's tripling. So if you doubled 2, you'd be at 4. If you doubled 3, you'd be at 9. So it's growing faster, right? When your x is 2 for doubling, it's 4. When your x is 2 for tripling, it's 9. So it's going to grow way faster, right? So instead of a 3, I'm going to put in here a 6. So it just grew faster, didn't it? Okay, what if I put in a 1.1? If I put in a 1, it's just good, but let's go 1.1. What do you think is going to happen? It's going to take longer, isn't it? What if I put 1? It's just a line. It's not an exponential graph. Because 1 to the 2 is 1, 1 to the 3 is 1, 1 to the 4 is 1, 1 to the 5 is 1. 1 to the x is actually the line y equals 1. It is not an exponential graph. Do you see that? So, what if I do this? 1 doesn't work. 1 makes a horizontal line. 1's out. What if I go lower? So I go 0.5. It decays because it's a half-life. You're halving and halving and halving and halving. So if you started off with 10, you're now going to have 5, then you're going to have 2.5, then so it's going to decay really fast. Okay? What if I put 0? I'm going to take some of these out.
Do a negative.
0 to the x. What's 0 to the 1? 0, what's 0 to the 2? 0 to the 3. 0, 0 to the 4, 0. So it's just a line y equals 0. So it's not an exponential as well. So 0's out, 1's out. Let's try negative. Negative 2. Remember, you have to put in brackets if you want negative 2 to the x. If I write it like this, that's actually negative 1 times 2 to the x. This negative 2 to the x, that negative's not with the 2. So if I want it to be negative 2 to the x, I actually have to go negative 2.
Why would that work? Because doesn't it just distribute the negative?
No, it does bedmass rules. It'll do the exponent first.
Then doesn't it distribute the negative?
No, it'll do the negative first. So if it does the negative first, or it does the exponent first, if you go negative 2 to the x, it's going to go 2 to the x and times it by negative 1. The negative 1 is your a.
Okay, why does that?
That's fine. We're not testing that, though. We're testing a negative b value. So if we want to test a negative b value, we're not. We're testing a positive b value multiplied by a negative a. And I want to test if b is negative. Yeah, it's going to fight you. Negative 2 to the x. It's not real. It doesn't exist. So your b value can be between 0 and 1, between them, and your b value can be greater than 1. Your b value can't be negative, can't be 0, can't be 1. So let's go over, let's put some rules on our b here. So b can be between 0 and 1. And when it's between 0 and 1, what happens? It decays. And b can be greater than 1. What happens when that happens? Yeah, it grows. What happens is b gets bigger. Your graph gets closer to the y, gets steeper, right? Gets steeper the bigger your b value. So we know that. That makes sense. Let's do this. That light is getting awful bright. I'm going to have to close the window. So say I do 0.5 to the x, which is actually a smaller decimal than 0.75, right? So 0.5 is going to be the blue. 0.75 is going to be the red. So actually, as your decimal gets bigger, your graph actually goes further away from the y. So the larger your number is greater than 1, the steeper, the closer it gets. But between 0 and 1, it's going to be wider out because it's going to decay less. Because there'll be 3/4 each time instead of 0.5 each time, right? So it's going to decay slower at 0.75 than it will at 0.5. Okay, so you're going to have that wider movement because the red is the 0.75. Okay, if on a test you forgot, could you not run some numbers through it? Go like 2 to the x, 3 to the x, 4 to the x, and see what happens, which one gets closer. If for some reason you forget, you could go 0.25, 0.5, 0.75, run those through, right? Your graph, if you don't have the colored ones, will always draw itself in the order of which you put it in. So your y1 will happen first, your y2 gets drawn second, your y3 gets drawn third, right? If you only draw 2 graphs, it's always better to make your second graph be the thicker one if you don't have the colors. Okay? So we went through all that. Let's go down here. What's the domain of that graph? XER. Or an interval notation, negative infinity to infinity. What's the range? Nope.
Oh, man.
Because if it doesn't just equal, if it just can't equal 0, then there's these negatives on this graph. There aren't any negative y's.
So well, that's one of them.
So for a rational,
Greater than 0.
it would be just not equal to the asymptotes. That's true. For this, it's going to be just greater than 0. Or greater than whatever the heck your asymptote is. And on a basic a, b to the x graph, your asymptote is always going to be y equals 0. If there's no transformations. So y such that y is greater than 0, y-er, or 0 to infinity. What's the asymptote at? It's a horizontal asymptote, yeah. Can I write HA on a test? No, the only short form you can do is LS equals RS. Intercepts. Does this one have any x-intercepts? No, because the asymptote's on it. Does that mean that every exponential will never, ever, ever have an x-intercept? No, because tomorrow we're going to do transformations. We're going to move it around. So these ones don't. In the basic a, b to the x, there are no x-intercepts. What about the y?
0, 1.
You also want to do this coordinate. Because that's where you get dinged as well in just not doing coordinates. So the only time you want to do just like x equals or y equals is if it's a line. So like the midline on the trig equation would be y equals 6. But an x-intercept, y-intercept should be coordinates. If b is greater than 1, you get the shape above. This is called an what? Increasing. You know that it has to start with a vowel because I use the word and in front of it. An increasing exponential function or a what's the value of a for this one? 1. So this would be 1, 3 to the x. So the value of a is 1. The value of b is? So is it increasing or decreasing? It's increasing. What's my y-intercept at? 0, 1. I'm going to ruin your life because we're running out of time. It's like going to the movie and being like, hey, Lassie died. That's what I feel like I'm doing right now. In the form y equals a b to the x, which we would discover on the next page, your a is always your y-intercept. So we're going to discover that on the next page, but I'm destroying it. Like I just walked into the movie and gave you the ending. I'm sorry. A, in the form only y a b to the x, it has to be in this form. The moment you transform it, move it, anything like that, if you move it to the right or the left, you've moved it, correct? Off of the y-intercept. Move it up or down, you've moved it from where it was. So it has to be an a b to the x form. No transformations. So what's your a on this one? 1. What's your b? 4. Which one's increasing faster? The 4. It's going to be closer to the y-intercept, right? Because it's growing faster. And my y-intercept is 0, 1, because I just ruined your lives. Okay, what's this one? My a? 1. My B, 5.25. So this one's growing even faster. So to be even closer to my Y. And then, or I'll curve up faster, 0, 1 again. How do the different bases affect the function? We did that above. When B is greater than 1, that is a B, you have you have a growth. As B gets larger, the graph grows faster. Which also makes it closer to the y-axis. Because it's going to get more vertical, correct? Faster. Then we're going to flip over. Oh, look. We're discovering something. I don't have time to type this in the calculators. So what's your A on this one? 1. What's your B? What's your intercept? 0, 1. I just ruined your life. You were supposed to type these all in and then figure it out. But yeah. Anyways. The A is up. The B is up. My y-intercept is now? Why is that? Use your transformations rule. Why is that? What is your A in front? What would this be? Vertical stretch. So your coordinate 0, 1. If I have a vertical stretch of 3, it's not going to be 0, 3, right? My mapping would be xy becomes x3y. Boom. That's why. That is the reason. Because it's actually a vertical stretch, and your graph without a vertical stretch, or when your y is 1, would be 0, 1. So now my A is 4, which is a vertical stretch of 4. My B is still 2. My 0, 1 is now going to become 0, 4, because I'm going to map it, multiplying my y's by 4. And then this one's 5.25, still 2, still doubling. This graph, every single one of these is doubling. That's not changing. But my y-intercept is changing because I'm multiplying my y by 0.1. By 0.1. By 0, 1 by 5.25. Don't worry. So how do the different coefficients affect the function? The B values will tell you if it's increasing or decreasing and by how much. The A value is your vertical stretch, which will give you your y-intercept if and only if there are no translations, right? No transformations happening to it. But moving it up or down, it throws that right out the window. But you do know that your basic function's y-intercept is 0, 1. So if I ever want to find a y-intercept, I can just use mapping to find the y-intercept, could I not? I could just use the mapping, all the movements, this is what we're going to do tomorrow, and map 0, 1 with the new mapping, and I get a new y-intercept every single time, because your basic function's y-intercept is 0, 1. Okay? Oh, what's going to happen with a third? I've ruined your lives. Like, I've literally destroyed all of the discovery in this lesson. What happens when B is a third? You're going to get a decay. Let's see why. So, I'm going to do 1/3 to the -3, which actually flips it and changes it, correct? So this would be, what's the power of a third? Or 3 to the 3? 27. So this is 1/27, but it's negated, so it's actually 27. This can be 1/3 to the 2, which is actually -2, sorry, which is actually 1/9, but then I have to negate it, so it's 9. This is 1/3 to the -1. Anything to the -1 just causes the entire fraction to reciprocate, so it becomes a 3. 1/3 to the 0 is 1, which makes sense because this function is y equals 1, 1/3 to the x. So my y-intercept would be at 1 still, right? No vertical stretch. And this one's 1/3 to the 1, which is a third. 1/3 to the 2, which is 1/9. 1/3 to the 3, which is 1/27. We're getting way too big, really way too small, I mean. 1/3 to the 4, I think is 164, 181. That's what it is. So, my horizontal asymptote did not move. That's the only thing that's going to move a horizontal line. What's the only thing that's going to shift this baby? Vertical translation. Which we're going to look at tomorrow. Our vertical translation is the only thing that's going to move our horizontal asymptote. So actually our vertical translation is our horizontal asymptote. What's a vertical translation on a graph of y equals 1/3 x? Vertical translation will be back here. It's 0. Woo, there it is. Y equals 0. And let's sketch the rest of the graph. So I have negative 3 and 27 is too big. Negative 2 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1 and 3. 0, 1. 1 and a third. 2 and 1/9. 3 and 127. 181. We're getting real close. Uh-oh, this is going to... I'm literally drawing over my dots with my... There we go. My hand was shadowing my dots. It should not be actually... It looks like it's moving upwards at the end. It should be like... strict. No. I did not mean to do that. Okay. What's my domain? XER didn't change, did it? It's just going downwards now. What's my range? It's the same. Y is greater than 0. The look of the graph changed, but it's still just above the x-axis, correct? What's my asymptote? Horizontal asymptote of y equals 0. It didn't change. Once again, HA can only be written because these are my notes. These are my notes, yep. Good talk. No x-intercepts. And my y-intercept is at 0, 1. I short-formed x-intercept and y-intercept. Am I allowed to do that on a test? Absolutely not. Write everything out. There is no time to short form except LSRS. Okay? If 0 is less than b is less than 1, you get the shape above. This is called a what? Decreasing exponential function. Or a... Okay. This is something to look at for tomorrow. We're looking at it ahead of time. The only way we can actually compare exponential graphs is if their bases are the same. So right now for this one, I have y equals 3 to the x, and then I have y equals 1/3 to the x. These are the bases, the 3 and the 1/3. There are actually no set of transformations happening here. I have to make these bases be the same, and then as they're the same, the number in front is your vertical translation or reflection. Anything with the x is horizontal, and then at the back is your vertical. So this 3 here actually doesn't come up anywhere in your SRT. But you can't do SRT if these babies are different. So how can I make this one B3?
I was going to say you should move it to the gate down, or I would have probably just done 1/3 to the negative x, so that it's all the same.
Yeah, so you can either change this one to 1/3, make this be a negative x, change this one to 3 and make it be a negative x. I'm going to change this one. So because it's saying how do I go from this one to this one? So I need to make this second one look like the first. So I'm going to make it be 3 to the negative x. What happens when I have a negative x? The negatives with the x, you have a reflection in the y. Let's see. Three to the x, 3 to the negative x. What's it reflecting on? The y. Now, do you see how it looks like it's drawing on the x-axis? Remember, your calculator is only so smart, okay? You are smarter than it. Don't be like, oh, it's drawing it on the x, must be there. It's not. If you go to your table of values, you're going to see it's getting like extremely 0, 0, 0, 0, like extremely small that way, or with the red, it's getting extremely small that way, but it's never touching 0, right? It's getting extremely close, but it's never touching it. And then this one here, it says, given the point negative 2, 16, negative 1, 4, 0, 1, what function of the form y equals c to the x can be used to describe the graph above? So my y-intercept is at 1, so I know my a is going to be 1. And now I need to figure out what's happening, and I can only figure out what's happening because I'm going up by 1. This is like that T table they used to give you in grade 9 and be like, give the explanation of what's happening. -2, -1, 0. I have 16, 4, 1. So these have to always go up by 1. Remember, that was the rule when you're in junior high. Then you can actually compare these. What's happening to these ones? They're dividing by 4. But remember, our rules can never use division. Dividing by 4 is actually like what? Multiplying by a quarter. Because they're decaying, my b needs to be a fraction between 0 and 1. Right? That's our rules. Your homework, I believe, shows up on the next page somehow. It's very top, but I'm going to give you a different. The wrong unit.
You heard me.
Yeah. 2 to 5. Now I want you to look at number 4 for a second. I'll explain it to you. Number 4 wants the equation. Did we not just do that? They want the equation of a graph. We agree? Now the key thing to this is they gave you a graph. But they gave you what? They'll give you 3 points, just like I did. So you just pull the 3 points off. So the first one is 2/9, 1/3, 0, 1. So if we want to make a t-table, we go up by 1, correct? So we go 0, 1, 1, 3, 2, 9. Going up by 1, going up by 1. What is happening here? It's tripling. It's going up by 3, correct? And what's my y-intercept at? 1. So what would my equation be? 1, 3 to the x. Do I need the 1 though? No. There, I just did 4a for you.